Hello everyone, and welcome to today's Windows IT Pro web seminar, Reduce Disaster Recovery and Business Continuity Expenses with Windows Server Clustering and Geo-Clustering, sponsored by StarWind Software. If you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. And if at any time you're having audio difficulties or issues with the advancing of the slides, simply hit your F5 key to refresh your webcast console. Please also be aware, today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow. You will receive an email when ready. And now, I would like to introduce today's presenters. Michael Odie, Senior Technical Director for Windows IT Pro and SQL Server Pro, is President of Tekka, a software development and consulting company in Portland, Oregon. Max Kolomaitsev is Product Manager for StarWind Virtual SAN. He has 7+ years of QA and technical support experience at StarWind Software and 10+ years of professional IT experience. He is also the host of the StarWind Technical Webinar Series. And with that, Michael, the floor is yours.
Thanks, Jake. Hi, my name is Michael Odie, and I'm Senior Technical Director for Windows IT Pro and SQL Server Pro, and today we're going to cover high availability with Windows Failover Clustering and Geo-Clustering. You know, availability is really one of the most critical concerns for the IT administrator. You know, it really doesn't even matter how well your systems perform if they're not available. Plus, as we all know, downtime, it isn't free. There are costs associated with the downtime that you may experience. In this presentation, you'll see how Windows Failover Clustering can be used to enhance your organization's business continuity, as well as providing disaster recovery capabilities. You'll learn about the different components of a cluster, as well as how you can stretch Windows Failover clusters across multiple geographic sites. There's a lot to cover, so let's go ahead and jump into it. First, one of the things I'm going to talk about are today's IT requirements. What are some of the driving factors that make IT require such high levels of availability today? And then I'm going to talk a little bit about the costs of downtime. Next, we're going to dive into the meat of the presentation, and we're going to talk about Windows Failover Clustering. You'll get an overview here of what goes into a Windows Failover cluster and some of the things that it takes to build those clusters. Next, I'll talk about some of the new features that were introduced with Windows Server 2012 and 2012 R2. A lot of important enhancements happen there, and it's good to be aware of what those are. And next, I'll talk a little bit about geo-clusters, or multi-site clusters as they're sometimes called. They can be used to really take Windows failover clustering to the next level and provide disaster recovery capabilities, in addition to the high availability that it can provide for local implementations. Then I'll talk a little bit about some of the factors that go into availability. Availability is really more than just a technological sort of implementation. There are a lot of other factors that go into it if you want to really create the most highly available sites and services for your IT organization. And finally, we'll end up with a few additional references. So that kind of gives you an idea of where we're going. So, about today's IT requirements, well, one of them is agility. Businesses have to meet quickly changing business conditions. Another one is complexity. It seems like as things go along, the IT infrastructure gets increasingly more complex. There's more interactive and moving parts to it. Today there's the cloud in addition to on-premise sorts of things. All these things add up to a lot of complexity, which makes it more difficult to manage. And increasing automation is one of the ways that you can adapt to some of these changes and handle this increasing complexity. And then there are other driving forces too. There's the consumerization of IT. End users now expect a lot more out of IT than they used to. They're used to cloud providers and service providers like Amazon and Microsoft and others, and so they expect a very high level of availability and accessibility from their end user services. And then of course there's always the driving factors for management to reduce costs, both capital costs, operational costs, and finally there's the need for data control and security. But all of this these are all certainly important requirements, but it's also equally important to have your services available. So availability, as I mentioned in the intro, is the most important thing that you can really work at. And downtime can be very, very expensive. In this slide, you can see a couple examples of the costs of downtime. Gartner did a study that shows that for downtime, and this is a study that was averaged across all businesses, so this may or may not represent your particular case, but they saw for an average, most businesses, and every minute of downtime costs them $5,600, whereas an hour of downtime could cost $300,000 plus. So downtime, and this is, for all businesses and averaged across all businesses. So you can see that downtime can be very expensive. In your particular case, it may be less, it may be more. For instance, look at Amazon. A 30-minute outage in 2013 cost them approximately $66,240 per minute. And so that would be about $3 million per hour. So you can see downtime can be very, very expensive, certainly in a monetary fashion, because you can't collect revenues, your websites and online services won't work if your services are down. But downtime is really more than just a dollars and cents kind of issue. There's also problems if your services are down, your websites are down. You'll have problems with your customers and end user confidence. They will begin to doubt your ability to provide your services. And then there's a case of reputation. Your reputation will be hurt if your downtime or if your services are down. So downtime can be both expensive, both in dollars and cents, as well as in confidence and reputation. So it's definitely something that you need to be aware of. And that's why businesses are working to maximize downtime or maximize availability and minimize downtime today. So if you're using the Microsoft stack and Microsoft servers, Microsoft Windows Failover Clustering is really their primary availability technology. It provides protection from unplanned downtime. It provides automated failover to where if one server goes down, another server can take over the load that's protected by that server. It's important to realize, though, Windows Server Failover Clustering, it is implemented at the server level. So all the things that are running on that server that are part of the failover cluster and part of failover cluster resources, those things will all be protected. So it's a server level technology. And this is different from other high availability technologies that you might have heard about, like maybe SQL Server Always On, which is at a database level, which is much lower level. The server level technology, the protection that you get out of Windows Failover Clustering, protects all the things on that server. So you can think of it like that. With Windows Failover Clustering, there's a maximum of 64 nodes. And when you go to add this is built in to Windows Server and basically has been for several releases now. So you add this as a Windows Server feature. You don't get a separate product to install or anything like that. It is important to understand, though, that this does require shared storage for this to work, because after all the different nodes in the cluster need to access the storage in order to share the resources that are available to that cluster. So what are some of the new features in Windows Failover Clustering for Windows Server 2012 and 2012 R2? Well, with 2012, and by the way, before I jump into that, Windows Failover Clustering sometimes has a reputation of being difficult to set up and hard to manage, and that may have been the case a long time ago, but with Windows Server 2008, Microsoft really revamped the interfaces, and Windows Server now 2008 and the newer releases of 2012 and 2012 R2 are much easier to manage and much easier to set up. And anyway, some of the new features here that you get with Windows Server 2012 is you now get 64 node clusters. This is up from 16 nodes that was the prior limitation. You can support up to 4,000 VMs per cluster and up to 1,024 VMs per node. And also one of the most important things, if you're thinking about multi-site and geographical clusters, is they added the ability to tune the heartbeat. And the heartbeat is something that happens in a cluster that allows cluster nodes to tell one another that they're still alive. I'll talk a little bit more about that in just a second. And Windows Server 2012 R2 added a couple of other important features. It now has the ability to use shared virtual hard disks. Virtual machines can be drained on shutdown. Virtual machine networks now have health detection, and there's also the capability of having an Active Directory detached cluster. Prior to this, Active Directory was a prerequisite to setting up a cluster. Your nodes had to be part of an Active Directory, and that's no longer the case with R2. So this slide gives us an overview of what a Windows Failover cluster is all about. And the bottom of this slide, you can see an example of a couple cluster nodes down there. These cluster nodes, in each case, they're having a couple of NICs. One of those NICs is going to a public network, and you can see that public network on the left side of your screen here, and that's where your client systems are shown. And the other NICs are going to, say, an example SAN storage in the back end. So you can see your SAN storage is using separate networking from your end user storage or your end user networking. And so these are separated on the network. And so it's important to realize then that these clients for your Windows failover cluster going through your public network, connecting to your cluster services that are running on those two cluster nodes. The cluster nodes then would be protected by Windows failover clustering. They would have a heartbeat that's talking between them, so that's how the cluster knows that each one of those nodes are available. Should one of the nodes be unavailable, those clustered resources will be restarted on the remaining node, and those client networks or those client systems will connect to those new resources running on the remaining cluster nodes with minimal interruption and downtime. And again, one of the key components that's making this work is that there is shared storage in the back end. So each of these cluster nodes is connected to that shared storage that's there. So with the cluster, one of the technologies that helps make the cluster work is something called a quorum. And basically, the purpose of the quorum is to allow or to let the cluster know how many nodes can fail before the cluster itself fails. There are three main types of quorums that are in use today. There's a node majority quorum, a node and disk majority quorum, and a node and file share majority quorum. With the node majority quorum, this is a more traditional type of quorum. It's basically used when there's clusters that have an odd number of nodes, and basically it allows for you to sustain half of the number of nodes that have failed minus one and still allow the cluster to operate. And this works because there's an odd number of nodes. So that means the cluster knows what's down. The disk majority was basically added to that, and it is a technology that was intended for clusters with even number of nodes. So if there's an even number of nodes, something called the disk witness will help decide if that cluster is still available or not. And in the case of a node and disk majority quorum, that disk majority is on shared storage that's accessed by both of the different cluster nodes. Now, one of the newer types is the node and file share majority quorum type, and this is important because it's used for geographically dispersed clusters or multi-site clusters. And here it's a lot like that node and disk majority. However, while the disk majority uses shared storage in the cluster, the file share majority quorum type does not. Instead, that witness is a file share that's separate from the cluster. And so it is used then, like I said, this type is used mainly for geographically or multi-site clusters. So how do you go about adding a Windows failover clustering to one of your implementations? Basically, you need to add the failover clustering feature. And it's not a role, it's a feature. You basically add it by using Server Manager. You go into the Add and Roles features portion of Server Manager. You drill into the features, as you can see here on the screen here on the bottom right-hand corner, and then you drill through until you select the failover clustering feature. When you select this, you'll get an added pop-up window that asks you to add the different management tools for the failover cluster, which you'll typically want to do, and you can see that in your small pop-up dialog here. And basically, after that, the system will go through and it will add all the failover clustering features to it. Remember, that is something that you have to do for each separate node that you want to participate in the cluster. Once you've added the failover clustering feature, you then have to go in and create the cluster. The cluster is created by something called the Failover Cluster Manager. Basically, to do this, there's a couple different steps, and the first step is to validate your configuration. And when you go in to validate your configuration, it is an option, as you can see, it's circled here in red right off the Failover Clustering Manager, and you basically go in, you select the different nodes that you want to participate in your cluster, and then the Failover Clustering Manager will run a number of different validation tests. And these tests will test the system hardware, the processors, the memory, it'll test the networking, as well as the storage for all of the different cluster nodes, and make sure that they meet the requirements of the failover cluster. If they do, then your failover cluster will function, and it will be supported by Microsoft as well. So there's There's no need for any specialized hardware or anything like that. If you or your system passes the validate configuration method, then Microsoft will support your cluster as you've created it on the nodes you've selected. So once you've validated your configuration, the next thing is to go ahead and create the cluster. And creating the cluster is a multi-step process. You can see right underneath the validate configuration node, there's a create cluster option as well. When you go into the create cluster option, basically, again, you select the nodes that are going to comprise your cluster. You're going to give your cluster a name and also a virtual IP address that's different from any other address on your network. Most companies assign a static IP address, but some of the recent changes have also allowed you to use dynamic IP addresses for your cluster. You select the quorum type that you're going to be using. By default, the wizard selects the quorum type that it thinks is appropriate, but if you're setting up a multi-site cluster or something like that, or you have special concerns, then you'll want to go ahead and change it, and then you're selecting the shared storage that the cluster is going to use. So it's a fairly easy to use wizard that steps you through the different processes of creating the cluster. So how are multi-site clusters different? Well, in a normal cluster, both of your cluster nodes, they'd probably be in the same location. Maybe they'd be in virtual machines, or maybe they'd be physical boxes. But anyway, they're typically in the same location, and they're typically set up to provide high availability. With a multi-site cluster or geographical cluster, here the main concern is disaster recovery. This protects against the loss of data from your entire location because your clustered services are protected not only in your location but off to a remote geographical site as well. One of the concerns, though, when you're setting up a multi-site cluster is, well, first there's the latency of the network between the different nodes. How do you make sure that they don't time out? And that's where the tunable heartbeat comes in. And then there is the storage that the cluster is using. Typically when these are set up, your storage, you'll have shared storage in each location, and there'll be some sort of replication that you set up between your shared storage locations to where your shared storage is replicating all the changes back and forth. Then if you have an outage on one location, all that shared storage has been replicated over to your disaster recovery secondary location. So what are some of the different practices in using multi-site clusters? Well, typically it's best if you set them up with an even number of nodes. You'll have a node on one side and a node and matching nodes on your disaster recovery site. You'll also typically want to use the node and file share majority option. In fact, you'll have to do this because the different nodes on the different sites will not be able to access shared storage like a disk majority cluster. So you have to use the file share majority option. And you'll use the file share witness that you'll typically set up on a file share that all of the different cluster nodes can access. One of the considerations, though, when you're using multi-site clusters is oftentimes when you're in different geographical locations, you'll have different subnets that are happening out there. And when the cluster fails over, the naming for those things will have to be propagated to your DNS. And so one of the things, so basically clients won't reconnect until the DNS replication has completed. So the time to life configuration on your DNS can have a major implication on how long it takes to do that. The cluster heartbeat, as I mentioned before, when you're setting up in a multi-site cluster, that's something that needs to be tuned to adjust for the latency of the network connection between your different nodes. And then, of course, you're probably looking at storage replication. In many cases, it's asynchronous to account for the latency and to make sure that your local applications still perform well. Another consideration that people don't often think about is that when you're, at least initially, when you have the different services on your cluster, it's definitely a good idea to make sure you're using the same sort of HBAs and NICs on each site so that they all have the same drivers and things like that, so there's no issues with any of those underlying infrastructure services when you have a failover. Now, we talked a lot about clustering, and clustering is basically one of the primary technologies to implement availability and disaster recovery for Windows Server systems. But you know, when you go to build an availability solution, there's really more to it than just implementing a technology. You need to make sure that the people that are operating these things are kept up to date and that they're trained and that they are able to know what to do in the case that there is a failover and to troubleshoot problems that may happen. So people are just as important to availability as technology. And the processes that you use are equally as important. It's important to have standards between your systems. That makes it easier for operators and especially junior IT personnel to know what to do in the case of a failover or other things. You need to have your procedures documented, and many organizations also need to have run books that help people, and especially junior people, know what to do in the case of a failover. All of these three factors work together to increase technology. So if you're looking at moving to 3 nines, 4 nines, or higher, then you'll definitely want to make sure that you have all three of these working together at the same time. So a couple of facts that I'm often asked about failover clustering. One, do I need specialized hardware for the failover cluster nodes? That used to be true in the past, but it's not anymore. You can use standard servers, and Microsoft will support the cluster if it passes the validation tests. Another question that I often get asked is, do all the cluster nodes have to be configured the same? And the answer is no. You do want to make sure that your failover nodes or the nodes you're using to support those failover services have the resources required to run those services once they fail over. So you need to make sure that your backup servers all have the adequate memory, disk, RAM resources that they need so that they're not overwhelmed and you can continue to meet your SLAs, but they do not have to be identical. Next, do I have to have a SAN if I want to build a failover cluster? And no, there's a number of ways you can implement shared storage, and clusters do require shared storage, but they don't necessarily need what you'd call a SAN like from EMC or something like that. But you do need a shared storage solution, and you can get that in a number of different ways. And next, can you implement a Windows failover cluster with virtual machines? And the answer to that is yes. You can implement failover clusters at the host level, meaning you could say implement a failover cluster with your HyperV host, using it to protect that host and all the VMs that are running on it. You can also implement a Windows failover cluster at the guest level within that host, and those guests could span multiple hosts if you want them to. So they can be implemented either at the guest or the host level. And finally, there's a couple additional resources you may want to check into if you're digging into failover clustering and looking at multi-site clustering. There's a good TechNet overview out there for Windows failover clustering. If you're looking at multi-site clustering, you might want to check out the TechNet article that covers requirements and recommendations for a multi-site cluster. I have a nice step-by-step article that's called Windows Server 2012, Building a 2-Node Failover Cluster, where I step you through all of the different steps of actually setting up a cluster on Windows Server 2012. StarWind also has a couple of nice papers on creating a Windows Server 2012 failover clustering using their StarWind SAN product, and Windows Server 2012 Geo-Clustering, which can help you see some of the nuances and insights into setting up a Geo-cluster. That's it for my portion of the presentation. I'm going to go ahead and hand it over to Max from StarWind. Thanks.
Hey, thanks, Mike. Thanks for having me here. And let me just switch over to the slide and tell you more about the storage component of the SQL clustering. So the idea StarWind brings to the clustering world and to the shared storage world is that instead of a dedicated proprietary SAN, which has been around for ages, we're trying to migrate into a SAN-less infrastructure, like you see on this picture on the screen. Instead of using a dedicated hardware box, we're just mirroring local storage, and that local storage is then presented to the SQL cluster, be it virtualized or be it just a physical SQL cluster, and the storage is synchronized on the back end. So the idea is that this configuration is much easier to deploy. It doesn't require proprietary hardware, it's faster, and it's easier to manage. So let me tell you a little more about the configuration and why we tend to go hyper-converged and why we excluding that proprietary layer. So first reason, we have zero hardware footprint. We do not need any additional hardware to run our cluster. We are not dependent on a dedicated hardware piece which may or may not be redundant, and we get everything within the servers we already have. This allows us to dramatically reduce both capital and operating expenses because we don't purchase new equipment. We don't have to think about repurposing that equipment when it goes out of service. We don't need to think about dedicated management staff for storage, which is usually the case. And of course, we do not spend money on proprietary storage area network interconnects and HBAs. Of course, getting away from the dedicated storage also allows us to prevent one more hardware lock-in in the environment. It also helps to do anti-vendor lock-in, so you still use the servers you like to use, but you're not dependent on the storage hardware. So there is no need to buy the same branded box every time you want to upgrade your configuration. One more important reason for going hyper-converged is that instead of 4 servers, which would usually be required for complete high availability, so 2 SQL servers in a cluster and then 2 storage units in a cluster to be completely redundant, StarWind does allow redundancy with just 2 servers and absolutely no additional hardware. And this redundancy does not come alone. It is accompanied by better performance, and it is accompanied by a lot of additional features a virtual SAN can offer against a hardware SAN or any other dedicated storage for SQL cluster or any other type of clustering. First of all, the virtual SAN reduces the I/O path to the disk. So what does it mean? In case of a hardware SAN, like in the previous picture, our information travels from the application layer to the CPU, is then transferred to the network, and then it goes down to the storage array. Then the storage array has some caching mechanisms, and then the block is actually written to the disk on the storage array. Instead, with virtual SAN, the data is sent to the CPU, and then it's sent to the memory, which acts as StarWind cache, which is essentially on the same machine. And this is where the client application gets an acknowledgement. So you get the performance of local storage, but that local storage is still redundant, highly available, and it has additional features. Now, of course, with this configuration, we want to have as many devices supported as the industry may need. So with standard servers you use for the clustering, and with Windows you have a really broad choice of disks you can use to store the data, you can use to increase the performance of your databases and any other applications you have here. So for this, StarWind specifically added support for high-speed PCI SSD, SAS SSD, as well as SATA SSD. So this is built in. It is really good for I/O. It is really good for latency, and it also allows us to add this flash layer not only as a primary storage tier, which is also a good way to use it, but also as a cache. So imagine you have multiple layers of storage within one server, and you also have the cluster running in the same box. So it's essentially a hyper-converged tiered cluster configuration. Your data is distributed, hot data stays in RAM, then some of it is offloaded to the SSD, or SSD is just used as a read cache, and then cold data resides on the spindles. Everything is really fast, all data types are comfortable, and the performance is always good, since there is no need to handle this type of tiering or copying the data on the third location like it was the case with the hardware SAN. Now, here are some components or ingredients or building blocks of high-performance storage. So as I mentioned earlier, StarWind utilizes RAM as caching, and to make that possible, to use RAM for write caching, but not only for read caching, and still maintain redundancy and keep the cache safe, we distribute our RAM cache between the participating cluster hosts. So should any of the hosts fail, the cached data is always available on the partner host, and there is no chance to lose the data which is inside that cache. Also, we do support a non-volatile cache layer if we put our flash cache in. So you just choose any SSD and provide it either as write caching for the LUN or as read caching for the LUN. I would actually prefer the second option because of a feature I'm going to talk next. So one more benefit of virtual SAN running on your cluster is that we do inline storage and cache deduplication. So every block you write to the storage effectively goes to the memory first. There, StarWind deduplicates this data. It checks if that data already exists on the storage. It checks if this is a new block, and then puts it in the deduplicated cache. Or if it's a new data, it writes it to the disk. So effectively, if you provision 1 GB of cache for your LUN, and you have a really repeating database where you have a lot of applications which have common data, you can squeeze much more than 1 GB of data into that RAM tier. And that means better performance. That means that more I/O hit RAM and never hit underlying storage. So if the underlying storage is all flash, we prevent that flash layer from burning out quicker. So it can definitely be called a flash-friendly solution. Now, the next feature for performance acceleration is the log structuring with our proprietary file system, which is LSFS. This file system is wrapped inside StarWind engine, so the user does not need to do some specific formatting on the client side. The disks presented by StarWind are still NTFS, RAFS, or whatever you format them, but inside it's just the way how StarWind handles the data. So the idea is to have lots of small random IOPS coalesced into one big sequential write, and then this write comes to the disk and is written as a full stripe. So even if you use a parity array like RAID 5, RAID 50, 660, you get good performance for writes, and you don't really have that 4 I/O penalty like with the traditional infrastructures. So say earlier, the maximum performance of the array would be, let's say, 1,000 IOPS. With StarWind, we've been able to exceed that number at least by 2 times with implementing storage log structuring. This thing also allows us to write in all flash configurations much more effectively. So instead of multiple small writes to the system, we do big writes, and then we never rewrite the blocks. We always erase them, free up some space, and then write the next big block. So it's another feature which allows us to preserve the flash from wearing out too quickly and also prevent it from spot burns. One more interesting thing about StarWind that it does not only do the storage tiering within one node, it also allows for internode storage tiering. So your cluster can actually offload the cold data to a separate array with high-capacity SATA spindles, and if necessary, this data is pulled back to the layer 1 and recached in RAM or in the flash layer on the primary system. This allows us to keep the primary storage system as minimalistic as it can be without the overhead of big disks which are used for the cold data. This technology also works for snapshots, and all snapshots can be simply offloaded to a slow array, and if necessary, you can always revert your configuration by pulling that data back to the primary side or to the primary system. And if we're talking about primary and secondary sites, this solution covers that part of the story as well. Since we already have a highly available configuration on our primary side, so we have our two nodes doing synchronous replication, we've got data highly available on the primary side, there should also be a scenario for a disaster recovery. So not only the backups, but a LAN-level replica, which will allow you to restore your productivity off-site should anything happen to the primary side. So we also facilitate asynchronous replication through WAN, which can be as slow as 5 megabits per second. And in case of a disaster, you can deploy the whole cluster on your DR side, or even if you don't have a cluster, it can be a single server which will be able to use that data from the primary side with really small RPO and RTO. And with that, I'd like to thank everyone for joining us today. I'd like to thank everyone for knowing a little more about StarWind, and I'll pass over the floor to Jake.
Fantastic. Thanks a lot, Max. And before we do begin the Q&A session, I would like to ask the audience to please like our survey by clicking on the red survey widget on your audience console. A few of you have submitted questions. We have some time for Q&A, so if you do have questions for Michael and or Max, please put that into the queue. And here's our first question. Do I need to have a JBOD to store the data for StarWind?
Okay, I think that's one for me. You don't really need to have a JBOD to store that data. It can be just local drives in each server you already have. If this is a server which has some storage constraints, like let's say a blade, you can have a dedicated JBOD for each server, and this JBOD will keep the data, and StarWind will mirror the data between two JBODs. This way we can provide high availability and full redundancy. So in case one JBOD fails, your application continue running, and we don't have neither a single point of failure nor an inverted pyramid of doom like a lot of people used to say on the IT communities, where you have a cluster relying on a non-clustered or non-redundant storage resource or non-redundant networking. So with dedicated storage to each node or with dedicated JBOD, we get true high availability and true redundancy.
Fantastic. Thanks, Max. Here's our next question. Can you clarify the statement about flash burning out?
Yeah, definitely. So the idea of flash burnout is that if you have some data which is used really often and is rewritten every day or even, let's say, every hour, this area of the SSD device quickly burns out. So with multiple instruments, we prevent flash from doing that. If this data is rewritten log-structured file system allows to distribute that load to different parts of the SSD. So you don't have that array of IOPS just bombing one part of the SSD. Instead, it's distributed evenly across the entire capacity of the array or of a drive, depending on what you use. And then with deduplication, if those bytes which form a spot burn on the SSD are repeated, they will simply stay in memory and they will never go down to the storage. So you will be effectively writing less to the actual disks while still writing the same amount of IOPS to your storage area network device.
Fantastic. Thanks, Max. Here's our next question also for you. How do I replicate or migrate data from StarWind file system to another file system?
Okay. So there is technically no such thing as StarWind file system. So we do have a proprietary file system, and that's how we call it because of the way we handle data. On the operating system side, on the cluster nodes where you deploy StarWind, you see the StarWind devices as files on your drive. So there will just be, I don't know, 10, 12, 100 small files which allocate portions of your disk or your dedicated partition which you entitled to StarWind. And on the client side, so when you create that device in StarWind and mount it over iSCSI, you will see it as an NTF, well, basically as a physical disk. You format it as NTFS and then provision it to the cluster. So there is no constraint in getting the data out, and even in case the whole system failed, you can move the StarWind files to another machine and there use another StarWind license and get the data out of the drive. You can also use our converter to convert StarWind devices from their format to VMDK or VHD if you want to virtualize your database, for instance.
Thanks a lot, Max. We have a question here about how StarWind is licensed and how much. Can you briefly touch on that?
I can definitely touch on the first part, but I'm not sure I can touch on the how much part. I'm not sure how much I can touch that part. So the StarWind solution is licensed per 2 nodes or more nodes for the high availability edition. We have the bytes license, which is 2 node 1 terabyte, and then we go incrementally up to 16 terabytes, and then we go unlimited. And then, of course, you can scale out the StarWind cluster beyond 64 nodes with either 2 or 3 copies of your data, and that is a different licensing model, which just adds, I think, fraction of the cost of the base license with every node you add. So I would say that the best way to get the idea of StarWind licensing and pricing is to contact our sales department. And should there be any technical questions, feel free to get in touch with StarWind support and we'll definitely help you out with the questions.
Thank you very much, Max. Here's our next question. Is RAM cache size configurable?
RAM cache size is configurable. It is configured per LUN. So every device you create in StarWind, you can configure RAM caching for it. You can decide if that cache is going to be write, read-write, or read-only. And keep in mind that this cache is distributed between nodes, so it's beneficial to use write cache because it's essentially non-volatile if the servers are configured properly and there is a backup power supply in the server.
Fantastic. Thanks, Max. Can you talk a little bit about what operating systems are supported?
Yeah, sure. So StarWind is a native Windows application, so we do support Windows 2008 R2, Windows 2012, Windows 2012 R2, and all the editions of these operating systems appropriately. So you can run this on data center standard. It can be a core version. It can even be the so-called Microsoft HyperV server, which is the free version of the Microsoft operating system.
Fantastic. And Mike, I believe this question is for you. Regarding the R2 enhancement of sharing virtual hard drives, I'm assuming that works for both ESX and Hyper-V hosts?
Well, that's a good question, but unfortunately the answer is no. With Windows Server 2012 R2 enhancements, that really only applies to Hyper-V VXX or VHDX drives, the newer type of virtual hard drive that's supported by Hyper-V. It unfortunately does not work with ESX VMDK files.
All right, thanks a lot, Mike. Here's another question for you, Max. If I want to have a two-way mirror using JBOD, I need 3 JBODs to handle 1 JBOD enclosure failure. If I have a cluster-in-a-box solution, what happens when one of the nodes goes down?
Okay, so with JBODs, indeed, clustered storage spaces do need 3 JBODs to tolerate 1 JBOD failure. That's kind of odd, and I hope Microsoft is changing that soon. But with a cluster-in-a-box solution, if one node fails, nothing happens to the application. So the cluster handles the failover, and cluster talks to StarWind as a multi-path device. So essentially, if one of the storage replicas goes down, the second storage replica is immediately available, and the failover is handled by the initiator-side multipathing. So Microsoft and Microsoft Failover cluster decide when to failover, and they just get to the second copy of the data. And let's say if we do a 3-node, in this case, if we have a 3-node cluster running SQL in StarWind, you can have 2 nodes go down and 1 node will remain active. So there, at this point, there is really no point in using the JBOD architecture because of its redundancy. I would really wait for the expanded feature set from Microsoft to start using JBODs.
Thank you, Max. Does StarWind run inside a Hyper-V VM?
It does not. It is a native Windows application, so it basically runs, as we say, in kernel. It's available to the user as a service inside the Windows operating system, so that's how users see it. And virtualizing StarWind may not be the best idea because of the overhead it introduces. And it's basically, it works as an application along with the cluster. It can be a SQL cluster, Hyper-V cluster, it can be any other application on the server. StarWind will just coexist with it, and as long as the application is able to use shared storage, it will be fine.
All right, fantastic. Here's our next question. So if you are installing the HSAN software on the Windows cluster node, would the DAS be attached?
Let's see. We're installing HSAN software on the Windows cluster node. Yeah, so the StarWind software makes use of the local storage or directly attached storage. So you can use the hard drives which are within the server box, or it can be, let's say, a dedicated SAS JBOD which is connected to that cluster. It can also be an external iSCSI SAN or old fiber channel SAN connected to that server. We have a lot of scenarios where people use StarWind on their Blade systems, and because of the space constraints, they just connect external hard drive shelves to StarWind and use 2 hard drive shelves and 2 blades to do the configuration I drew out on my first slide, like 2 servers, and their storage is just directly attached to each of the cluster nodes.
Fantastic. Here's our next question. Do we have the option to specify alternate witness server?
This is Mike. I'll handle that one. I assume you're talking about a file server witness when you're setting up a quorum with a file server majority node. And the answer is not really. You can't set up an alternate witness server, but you can have the file server witness itself set up in a protected fashion. For instance, the file servers could be on another Windows Server cluster that in itself is a highly available solution. So you can't have alternates where there's like failover from 1 to 2, but you can set it up in such a way that that file server witness is highly available.
Right, and I would actually add to that answer saying that StarWind does also handle the quorum. So if you have a multi-node cluster, you can simply mirror the data between multiple hosts and then export that as a dedicated drive, which the cluster will use as a quorum. So in this case, even if you have 2 nodes, your quorum is mirrored between 2 nodes, and one node fails, one node stays alive with the quorum available as a local copy of the data. So this may be an alternative solution.
Thanks, gentlemen. Looks like we have time for one more question. What benefit, if any, does overlaying this feature with a product like DoubleTake offers? I'm just trying to understand the HA capability for this feature. And also, in addition to that, do you have any white papers or trials that we could try out?
Yeah, so we definitely have white papers and trials. I would just send the link, but I'm not sure where to send it, so I'll just get the email after the webinar to send that information over. Compared to DoubleTake, StarWind's idea is a virtual SAN, and DoubleTake is more about handling the data replication between the hosts. So we do work with storage on the block level, we do cache it in RAM, and we do then structure the data. This is not something what DoubleTake mentions as the primary value add of their solution, and that would be the most basic explanation. I don't really want to get too technical, and I can gladly continue that description in a one-to-one conversation or a call, gladly.
Fantastic. Thanks a lot, Max. And I am afraid we have run out of time for this web seminar. I'd like to thank StarWind Software for making today's event possible. And of course, I'd like to thank Michael and Max for their great presentations. Just a reminder, this web seminar will be available on demand starting tomorrow, so feel free to come back and review. Have a great day, everyone, and thank you so much for attending.